this video we will be talking about the operator precedence. So what do you mean by precedence? So precedence is the process of executing certain variables and operators in a certain way to execute a certain information. For example, you have learned in mathematics like Bodmas rule. So Bodmas rule is what? Bracket of division, multiplication, addition, subtraction. Similar to that, Java also has certain set of rules so that it can execute a certain operation. So first of all, we are going to learn that how it is being executed. Then this becomes your precedence. Then we will learn about associativity. So associativity is the process of which operator should get the first preference when a certain set of operands are getting executed. So first of all, you are going to see that parenthesis or function call. This is left to right associativity. So when it will be founded by your interpreter, it will be executed from left to right. Then your brackets or array subscript, then the dot operator, arrow operator, then post increment. Just remember that this is post increment. Post fix, we have studied in the previous classes that if a variable has the operands in the left side, on the left side, then it is prefix. Pre means before, and if the symbols are on the right side, it is postfix. So postfix has associativity from left to right. Then here comes prefix. So prefix I have just said, if the symbols are before the variables, then it is prefix. So prefix can be both increment and decrement. Then unary plus minus. This is unary because example plus a. Suppose b equals to plus a. So this becomes a unary. In that case, that will be right to left. Then not operator and bitwise complement typecasting, that explicit to implicit operation. Then falls under this. So this is the first level. If this comes, this will be first executed. Then this is the second level. Then your multiplication, division, that is the division, normal division where we get the quotient part, and modulus is the division where we get the remainder part. So this comes under third. This has a associativity from left to right. Plus minus, normal plus minus, that is addition subtraction, left to right. It just comes under the multiplication, division, modulus. So basically you can see a pattern of Bodmas rule, right? So after multiplication, after division and multiplication, then comes your addition and subtraction. Bitwise shift is not there in your syllabus, so we will not cover this. Then your less than, greater than, less than, greater than, less than, equal to, greater than, equal to. These are all left to right. Then equal to operator, left to right. Bitwise and, bitwise or, then exclusive or, logical and, logical or, and ternary operation. These all fall under the left to right, but just ternary operator is right to left. Then assignment operator, where we will be finding out that b equal to a. So it will follow from what? Right to left operation. So and along with that, all the shorthand operations will be as follows. So these follows a hierarchical part, right? So this 6, 7, 8, 9, 10, 11, 12, and lastly the comma, 13. Now we will be looking into some equations. So here in your page number 95 of Total Computer Applications book, there is a question number 16 where int a equals to 10, b equals to 15, and c equals to 25. in your examinations this kind of question may be asked. So let us try to solve this. So first of all, since we have already learned that if the AND operation occurs when both of the conditions are true, right? And the not operator does what? If a not operator, if there is inside true, then it will convert that into false, and vice versa. Suppose here we have what is given, C is greater than B, so C is greater than B. Let us see. So 25 greater than B is what? Definitely it is greater than B, so it will be true. And here in the right hand side, B is greater than A. B is greater than is what? 15 is greater than 10, right? So it's true. Now what I have just told you that when AND operator only shows true when both of the things are true, right? So inside it is true, but since we cannot write true like that, okay, because this is a integer type. This is a integer type. So for integer 1 is true and 0 means false. So basically it will hold a value of 1. And since it is a not operator, not operator will convert it to the reverse part. So you will getting an answer of 0. So D will hold the answer of 0. Okay. Now next question. On page number 93, assignments part 1, this kind of thing is given. So you just remember that multiplication, division, modulus, left to right, addition, subtraction, right, left to right. So first of all, you will be doing the multiplication, division, or addition, multiplication, division firstly, and then you will be moving forward into the subtraction and addition. So first of all, we will be doing this part. So 10 divided by 4, since it is a modulus, so it is what we will be getting, 4 divided by 4 2 is 8, remainder is 2. So here it will be 2 plus 2 minus 6 plus 7. So ultimately what will the answer? So if you go from here to here, this will be 4 plus 2 plus 7. Your answer, you will be getting an answer of 13. Okay, moving forward. Now here you are seeing that plus x. So you have in your previous class I have taught you that in prefix, first of all, in prefix the value gets incremented first and then gets stored into the assignment operators variable. Okay, so here, and also we have to take in consideration that here we are facing a parenthesis operator, and in the parenthesis operator it is in the very first location. So left to right associativity. So we will be getting inside the parenthesis operator. That is why I have chose the parenthesis operator, but I could have chosen also the z plus plus, but since it is according to the associativity and precedence, so we will be doing that. So plus x, it will be 1 plus y, since it is in minus minus, y minus minus, so y minus minus, since will be minus 1 after it has been stored inside a variable. So since it is a postfix, since it is postfix, so basically the value of y will stay same. After the equation it will become minus 1. So 0 multiplied by now z plus plus. So z plus plus is what? Z plus plus is again your same thing. It is not being incremented anyway because it is a postfix type. See, after the variable is being supplied to the right hand side of the to the left hand side of the assignment operator, that is x here. So it will stay same, 0. So it will become 1 plus 0 is 1 multiplied by 0 is 0. So your answer will be 0. Now, so we have done the arithmetic part. Now there is a little bit part left, that is your expressions. Now expressions in Java, their expression is any Java any valid kind of operators, constants and variables and methods which are constructed to a different part. So for example, what you have seen here, these are all expressions. These are all expressions in Java. These are all expressions in Java. These are all expressions. Now expressions can be of 4 types. pure expression, mixed expression, complex expression, and logical expression. So what do you mean by pure expression? Pure expression is where only a single type of your operand can be stored. For example, pure expression, suppose int a equals to 10, b equals to 20, and c equals to something. Okay, so let's initialize by 0. So a equals to a plus b, a plus b. Let us increase the thickness of the pencil. A plus b a plus b. So so here you can see that only one type of operand. Actually, I want to say that one type of operator is there, only plus is there. Okay, for that kind of thing, so this is a pure expression where only one type of operator is being used. Suppose only plus, only minus, only multiplication, only division symbols. Okay, these are pure expression. Then you have mixed expression. Mixed expression um, where the operands are of different types. Here in pure expression, only one operator has been used, and also the operands are of same type. That is integer. Both are integer, and we are storing inside the same integer only. But in mixed expression, suppose float. Pi. Okay, so suppose float pi. So pi equals to 3.14 f. So why I am writing f? Because in Java, if you don't write f at the end of a floating point value, it will show an error, because Java always gets stuck to a double type for any decimal values. For that purpose, that is why you should be writing 3.14 f. But in case you have written double equals to pi equals to 3.14, then it won't be an issue. Okay, since I have written in float, that is why I have to write f to show the Java compiler that it is a floating type. Now then, suppose int radius. Radius may be, suppose radius equals to 5. Okay, now then, since always remember that when choosing between the so you have to choose that which is the higher. So basically, you know that float is higher than int. That is why we will be choosing the value. So that the value where we will be storing this operation. So always remember that when choosing the variables, always remember that whenever the highest variable's data type is there, always choose that. So between int and float, definitely float is greater. So we will be choosing a output where we will storing the operation should be a float type. So float, suppose area. So area is arc is what? 2 pi r square. Pi r square. So pi multiplied by radius multiplied by radius. So this becomes your mixed expression. Then where is square? So now this is your mixed expression. Then your complex expression. So complex expression is a type of expression where we will be using more than one data type, and also where we will be choosing the more than one operands. So in the previous examples, we have been seeing that we only be using only one type of operator, only multiplication or only plus. But in mixed expression, we are using the different data type. In complex expression, we have to take in consideration that the previous in the arithmetics we have did that uh, where multiple types of operators are there, and since there are multiple types of operator, we have to take in consideration of precedence and associativity of operators. So the complex for complex expression, for example, let us write a complex expression. Short result. Short is a type of data type. Byte short, int long. So short is just one step lower than the integer type. So short result equals to, suppose, 100 plus 4 multiplied by 9 divided by 3. So if you did simple like this, 100 plus 4 multiplied by 9 divided by 3, so definitely you will get a wrong answer. Since here we will be taking consideration of precedence, so and the answer is what? You have seen that multiplication, division, modulus all have the same precedence, since they lie in the same level. So if you did like this, 9 divided by 3 is 3 plus 100, so the answer is what? 112. Okay, so this is a complex expression where we are taking more than one operators, and the evaluation of the expression is performed on the basis of precedence of operators and associativity. Then comes your logical expression. Logical expressions are those where we will using the logical operators like greater than, less than, greater than, equal to, less than, equal to, not equal to, this kind of operators. For example, suppose x equals to 5, b and y equals to 10. Now if I written like this, if means this is a conditional construct we will be learning in the later chapters, that if x is greater than y, then show something, else show something. Definitely x is greater than y. No, it is not greater than y. So this is a false statement, right? Where we are taking true and false as outputs. So this will go into the else part. Now if I had written like this, if x is less than y, definitely the first part will be would have executed. So this kind of construction where conditions where the true and false statements are being taken in considerations, and these true and false outputs are based on logical expressions and boolean expression. These are called logical expression. These types of expressions are logical expressions. Now statements. So basically a statement is a form of a complete unit of execution. So suppose price, let us give some examples. Suppose price equals to 504.99. So this is a statement where it has an assignment statement followed by a constant value, which is a literal, and assignment operator, and a variable where we are storing the value. So since it's we have already learned this, so then let's see that very common statements, system.out.println. So this statement is being used to print anything onto the screen. So hello world. So this is expression of your statement. So these are what is called method invocation statement. Okay, then for example, if you have written price equals to price plus plus, so this will be an increment statement. And for example, if we create an object of a class, suppose card, suppose Tata equals to new card. So basically Tata is the object of card. So this kind of statement is called object creation statement. Now let us see something about blocks. So in Java, a block is a group of statements between braces and can be done anywhere. So for example, here you are seeing a block. I have written a program called circular prime where I have defined a certain functions or methods. So you are seeing that This is a certain block. This block contains a set of statements which predicts a certain rules. So I have made a function of prime with a data type boolean and with a class modifier as protected. So prime. So for example, if you go down, so I have written another function called reverse with a parameter of int n and a data type of return type of int, and within that I have written a set of functions which does a set of things. Basically it reverses a number. Suppose you give 12, you will get 21 out of that. So these are blocks. Now we will be learning about the new operator. The new operator in Java is responsible for creation of objects. It dynamically allocates memory to a program or to a class object. Example, suppose I'm writing a class, suppose class car. So a car has what? A set of wheels, a color, and speed. These are the basic things. So color may be red, blue. So we'll be defining the data type of the variable color as string. Then suppose int speed and suppose this is speed and brand. So string brand or model. Okay, so this is a class of car. So to make an object of this car, we need to write like this: car. First we need to write the class name followed by an object. Suppose the object may be, suppose Tata. Tata is the object of car, followed by assignment operator, and we are writing the new operator. So the new operator will assign certain memory to the object of car. So the car creates an object of car creates an object of basically Tata is an object of class. So car is a class of object, and inside the Tata object, which is the instance of class car, and we will be providing some data inside it. So the initialization is done using a constructor of class car. So this constructor will go inside the object Tata and will give some memory inside it, and this is being done using the new operator. This is being done using a thing called dynamic memory. Dynamic memory is that you don't assign a certain amount of fixed memory. This memory can change based on the usage of this class. Now what we have done is that this is called initialization. Initialization is providing some value inside a variable or a object to provide it with a certain amount of memory, and the car is the class. From car we are creating an object of Tata. This is called instantiation. Instantiation is the creation of objects from a class, and when we are supplying some values inside the object, we are initializing it. Now we will be learning about the dot operator. So basically the dot operator allows you to invoke the certain data members. These are called data members inside a class. So we have made an object of Tata. Now to utilize these things inside the class, we need to do this tata followed by dot operator. Then dot operator will allow you to use this color, speed and model variables. So tata dot color equals to suppose blue. So basically you are assigning some values inside the data type. Then tata dot speed, basically without using the dot operator you cannot access the contents of the class car. So use through an object followed by a dot operator, you're accessing the fields inside the class. These data members are also known as fields. So tata dot speed, suppose let us keep a speed of 40 km per hour, and model suppose Nexon EV. So this is how the operator is done. Now the final part, displaying data onto the screen. To display our data onto the screen, we need to use the system.out.println. So let us write a program to demonstrate this thing. So here is a window of BlueJ. Now I will create a basic class. So I will give a name of class as display. Display. Then press OK. Now you have to find out a display class. You need to right click and click on open editor. This will open an editor in front of you. These are the tabs which I have used. So let us close this tab, and then you need to do is Control A to select and click on backspace to delete everything. Now let us write a program class display. Then braces. Then you have to write public static void main. Public static void main is enough. Then you have to create another braces. This is a block of code, and since you are writing the coding for the first time, so you are displaying some values in front of your screen. You need to write system dot out. This is basically to show the whatever you are passing the data inside the println class, println function onto the screen. So system.out.println, this is a test of SOPLN. SOPLN is a short form of subsystem.out.println. We'll be using this frequently in our further classes. Followed by brackets. Then place on compile, click on, then close this. Then right click and click on void main. So here you are seeing this is a test of SOPLN. Basically, this code allows you to display certain variables or data inside it. You can also display some data also. Suppose let us write a addition of numbers. Suppose int a equals to 5 and b equals to 6. Then we need to also do the sum. Sum equals to 0. We are basically initializing, not assigning some value inside it. The sum equals to a plus b. Now the addition has been done. Now you want to display this out into the screen. So how do you do that? You write system.out.println. So you want to display something meaningful in front of the user. So the addition of two numbers is, close the double quotes, plus then show up the variable. Compile and close the tab. Right click, void main. So addition of two numbers is 11. So this is how you are displaying some values in front of the user. Now there are two types of system.out printing function. There are two types. The first is your system.out.print and system.out.println. The basic difference is that when you are using system.out.print, a new line is not created after that. So let us see. So suppose I have removed this thing. So when this line will execute, this is a test of SAP line will show up, and after that new line will not be created, and this basically what we will be seeing that this dot SAP line without any going to next line, this will be printed on the sideway. So let us see. Just tap on that. And click on white matter. So you can very well see that this line is being printed. After that no new line has been shown up, and the next line is being printed up here. But if you use this ln means new line, print new line, and print basically is that you just printing a thing and you are not printing, and after that you are not printing a new line, a blank new line. So if you do this, it will show in a correct order. This completes our chapter, operators in Java.